to 10, and now I set x to 15, and x is both 10 and 15. So a lot of times people will talk about variables as if it's a box. And so I'm going to put in this x box the number 10. But also I could put another number into that box. And that's not how our variables work. Our variables have a particular value at a particular time. Or another way to think about it is we only have one box in this context.
The box can only hold one thing.
And so I think helping students, trying to get inside how students are representing this and how students are making sense of this, really productive. I think also helping students recognize the goal that you should be able to predict what a given command will do. A lot of times it's just like, oh, well, let me just try it. Oh, no, another thing we should be able to do is not just throw pieces together and get them to work, is be able to explain why they work. And that has been more of a struggle for me in working with Scratch than in working with Logo, because Logo, students would be like, it's so hard to type this. Let's talk about it. Are we sure that we want to type 100? Are you sure it's, okay, I think it's 100. Right, and it took them all day, and it was just like dialogue, dialogue, dialogue before they tried it. In Scratch, it's not that way. Even with one student, like drag, 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 double click. No, that didn't do it. Drag, drag, throw it away. Drag, 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 double click. No, that didn't do it. And I think that this is a really reasonable pattern for students to get into, but you need the trial and error. Once you figure out what does work, you need to try and figure out why it does work. It's not always productive for students to try and understand everything that they created, why that didn't work, but at least when they get something that works, I want them to understand every block in there, why it works. Can I take that one out? What about that one? Can I take that one out? Does that make sense? Your students, if you do Scratch with them, are going to want to build a platformer game. Let me just throw that out there. It's hard to build a good platformer game. There's really, really complicated things that happen in terms of concurrency. You have the platform is telling me to go up, and I'm telling myself to go down, so that when I'm not on the platform and it's not telling me to go up, I fall down. There's a lot of inelegant solutions, and there's a lot of, it's very, very hard. So I'm going to show you an example that is not that hard and is really within the grasp of your students. Oh, and many thanks to Standish123. I found Standish123's Project Adventures of Jerry the Ball on the Scratch website, which I'll show you in just a second. And then I ripped a lot of stuff out because you don't need the bells and whistles. Here's the general idea. Here's Jerry the Ball. And most of the time when you're playing the game, you just see the red ball with the black lines on the outside. They also have another thing, which is these sensors. So in Scratch, I can have multiple sprites. So here I have the sprite, which is a ball, and a sprite, which is a set of sensors. These sensors are the player's never going to see. We always keep these invisible. But because they're there, I can detect if this color red, this exact color red, is touching a black line. So I can say, you'll notice in this picture before, all of the shapes that Standish123 drew all had black lines around the outside. So then I can say, well, if yellow is touching a black line, then that means I can't walk right anymore. And if green is touching a black line, that means I can't walk. I mixed up the directions, but you get it. Or if blue is touching a black line, that means I've hit my head on something. Okay, so each of these lines separately can tell me in which direction I can no longer progress. Okay? So what we can do is we can show what we can create variables to say, nah, can't go to the right anymore. Nah, can't go to the left anymore. Okay? And so here, this is one of the representations of variables in Scratch. It'll show you the value of the variable in Scratch. Computer scientists are in the room are going to say, why don't you just use ones and zeros instead of trues and falses? These are literally the words true and false. Okay? But what each of these variables means is Am I touching something on my up side? Am I touching something on my right side? Am I touching something on my left side? And using I've just had a lot more success with students where I'm saying literally false or no and yes. Actually, no and yes is probably even better. Is there something on my up side? No. Okay. So that's the general framework of how all this is going to work. Is I have these sensors around the outside and they're going to set these variables. So let's look and let's just assume that those variables are set correctly. I've written this set of sensors, it works perfectly. So now what I have is, I have a character that I want to be able to jump. And I want it to fall when it's not touching a platform. So I say, well, I have a forever around here, which means it's going to go top to bottom, top to bottom, top to bottom, top to bottom, until I'm done. So I say, if the key up arrow is pressed, so if someone is literally holding the button down at the moment when it tests this, then I'm going to do this thing 15 times. The thing I'm going to do 15 times is I'm going to say, if I haven't hit my head, change my Y by 4 and go up 4 pixels. If I haven't hit my head, go up 4 pixels. If I haven't hit my head, go up 4 pixels. If I haven't hit my head, go up 4 pixels. And I do that 15 times. When I'm done, I say, well, all the other times, all the times when the key up arrow is not pressed, let me just say, as long as I haven't hit my feet, go down 4. If I haven't hit my feet, go down 4. If I haven't hit my feet, go down 4. So until I hit my feet, until I touch the black again, I'm going to keep changing Y by -4 and keep going down. Does that make sense? So this gives me both the jump up here, and this bottom piece gives me the gravity. It's all in a forever, and so this is going to happen top to bottom, top to bottom, top to bottom. Brian Harvey, you look upset.
If you're falling, you can't push the up arrow.
Yeah, but that's...
You have to have fallen.
Yeah. So that is... maybe you're critiquing that,
yeah.
But something that I think is a bummer is in games, if I'm I'm sorry. If I'm mid-jump, I shouldn't be able to jump again. I should have to be touching something on my feet to be able to jump, to get lift off. Otherwise, if you don't have this kind of block, okay. I can jump and jump and jump and jump and jump. It's kind of like flying. Yeah. Sometimes that's what you want. Here's something your students are going to do. They're just going to leave off this forever. Okay? I think that this one is just another mistake. I think professional programmers would forget the forever when they were working on this. So the question I ask students that seems to get the response I want is, oh, if I put a note on top of this if, how many times would it play? They say, what? Oh, forever. Or the other thing I'll say is, how many times do you want this to happen? That question they have more trouble with. Once they've caught themselves forgetting forever a few times, that question works better. But if I put a note on top of the if, how many times would it play? Seems to cue the, oh, I need a forever. Yeah?
Wow.
Yeah, Dan?
It's not gravity, right? Because they
oh, no, it's not gravity.
Oh, okay.
Yeah, and I think if students have this kind of framework, they could develop gravity where it goes faster, faster, faster. This ball actually reaches its terminal velocity instantaneously.
Nice.
Yeah. Yeah. Okay. So now we're going to zoom in onto if the left arrow is pressed or if the right arrow is pressed. They're identical, so I'm just going to focus on just the left arrow. We'll go back to that other one, but there was a whole other chunk down here of if the right arrow is pressed. If the left arrow is pressed, this little guy's really cute. He rolls when he moves. So what he's going to do 10 times is if you press the left arrow, he's going to turn 36 degrees. Okay? So he turns. If he hasn't run into something on the left-hand side,